All right, got a little problem of the day here to get you started. Just a reminder, probably the fastest way to get through this would be to do your stem and leaf plot first. That way it puts everything in order. It makes finding it makes making the frequency table easier, which makes the histogram easier. Then you can use your stem and leaf. Since the numbers are already in order, it makes it easy to find the range and the median and the mode for your set of data. And then don't forget to find the mean, and then also identify the median, the extremes, and the quartiles in number 7 on that box and whiskers plot. I'm just going to add these lines here so you're clear as to where this box and whiskers starts and ends. Just as a reminder to get you started here with the stem and leaf and the frequency table and the histogram. Remember, the stem and leaf has to go in order. Our smallest number was 50. So what I've done here is I filled in all the 50s for you on the stem and leaf, the frequency table, and then the bar on the histogram. So you need to go ahead and finish it for the 60s, the 70s, and the 80s. And then again, don't forget range, mean, median, and mode, and then identify those values off the box and whiskers that it asks for as well. All right, here to check the problem of the day. Again, look at your stem and leaf, your frequency table, and your histogram here. Just make sure that, again, that stem and leaf, it has to be in the correct order. And then again, you can use your stem and leaf to make your frequency table, use your frequency table to make your histogram. The second question there was to find the range, mean, median, and mode of that data. Well, the range you can find easily off the stem and leaf. You can see that the highest number is 89 and the lowest number is 50. So 89 minus 50 is 39. Your mean, remember, you're just adding up all the numbers in your data set. And so if you did that with these, it should add up to 1,045. And then you want to divide by 15 because there's 15 pieces of data. So that's 69.6 repeating. If you put like 69.67, that's fine. Median, that's your middle number. Again, your stem and leaf will help you with that. There's 15 pieces of data. So you'll notice that on each side of the median, which happens to be 66, there's 7 pieces of data lower than 66. And there's 7 pieces of data higher than 66. 66 falls right in the middle in this case. Mode is 58. You can clearly see on the stem and leaf there's 2 58s, and there's only 1 of all of the rest. So that helps you with that. And then lastly, on your box and whiskers plot, you just had to identify the median, the extremes, and the quartiles. Just put them in order there. The lower extreme is 20. The lower quartile is 23, that's the left side of your box. The median is 26, that's the middle of your box there. Upper quartile is 28, that's the right side of the box, and then the upper extreme is 34. All right, today we're talking about probability. So we want to identify the number of favorable outcomes and possible outcomes in an event, and then calculate the probability that an outcome will occur. So our first example here involves flipping a coin. So again, probability is the chance or likelihood that an outcome will occur. To find probability, we use this fraction, which is we take the number of favorable outcomes divided by the number of possible outcomes. The favorable outcomes are what you're looking to see happen. Okay? So in the coin example here, suppose we toss a coin once, what's the probability that the coin will land heads up? So our favorable outcome is the coin landing heads up. Well, there's only one side of the coin is heads, so there's one favorable outcome. Possible outcomes, well, there's 2 possible outcomes. It could either be heads or it could be tails, so there's 2 possible outcomes. So the probability of tossing a coin and having it land heads up is 1 out of 2. Okay, 1 over 2 for the fraction. And just like anything else with a fraction, we're always going to put them in simplest form. In this case, this one is already in simplest form. All right, next example here involves rolling a die. Okay, so they're calling it a 1 through 6 number cube. Same thing as rolling a die. Okay, what is the probability of rolling an even number? Well, if there's 1 through 6 on there, that means the numbers 2, 4, and 6 are the even numbers that would be favorable. That would be even numbers. So that's where the 3 on top comes from. Possible outcomes, well, there's 6 numbers on the cube, so there's 6 possible outcomes. And if you simplify that, the 3 over 6 will simplify to 1 over 2. So it kind of, as you roll it here, so there we rolled it once, we got a 5. Second time, we got an even number of 4. Now, is that always going to happen? No. It's certainly possible to roll 2 odd numbers in a row, but the more times you do it, the more likely you are to end up with rolling half the time odds and half the time evens. On the rest of this slide, the probability of any event will always be 0, 1, or between 0 and 1. So the probability of rolling a 1 through 6 number cube and rolling a 7 is 0 because the outcome 7 is not possible. So there's no 7 on there. So we have 0 favorable outcomes. That's why the 0 is on top. And then, again, there's 6 possible outcomes, 1 through 6. But remember, 0 divided by anything is 0. So if the probability of an event is 0, we say it is impossible. Okay, so anytime it comes out to be 0, that's impossible. The next example of tossing a coin and having it land heads up or tails up is 1 because either outcome is favorable. So if I say, it can be heads or tails, that means I have 2 favorable outcomes out of 2 possibilities. So 2 divided by 2, remember anything divided by itself is 1. Anytime your probability comes out to be 1, we say that that event is certain. Okay, it's going to happen. So if the probability of an event is 1, we say it's certain. All right, we're going to look at this example with the spinner. So you can see the spinner. We have 1 red part of the spinner, 2 yellow segments on the spinner, and 3 green. All of them are, each segment is the same size. Okay, so it wants to know what's the probability of spinning yellow. Okay, well, yellow, there are 2 yellow spots, and we have 6 spots altogether, so that's 2 out of 6. Again, we want to simplify that. So the probability of spinning yellow is 1 out of 3. So if I spin the spinner, if I were to spin it 3 times, one of those times I should get yellow. Now, is it a guarantee? No, it's not a guarantee. You can see I just spun it 3 times and I didn't get yellow. But again, as you were to do this more and more often, eventually it would come to that. So next one, green. Green, we have 3 segments. Again, and there are 6 of them. 3 out of 6 will reduce to 1 out of 2. Red, well, there's only 1 red segment out of the 6, so that's 1 out of 6. Okay? Now, number 4, when you see the or, anytime you see or, that means plus. You're going to add the probabilities together. So my probability for yellow, we simplified it to 1 out of 3, but I'm just going to go with the 2 out of 6 here. So if I take the 2, 6 plus the green, which was the 3, 6, Okay? 2, 6 plus 3, 6 is 5, 6. So there's a 5 out of 6 chance when we spin this, we're going to spin yellow or green. And if you look at your spinner, there's 5 segments that are either yellow or green. Okay? Now the probability of spinning blue, well, there are 0 blue segments on there out of 6. 0 divided by anything is 0. So remember, spinning blue on this spinner would be impossible. You can't do it. Okay, and then red or yellow or green. Again, remember when you see the or, that means you're adding those probabilities together. So for red was 1, 6. Yellow was 2, 6. And then green was 3, 6. Now I'm doing the ones out of 6. I'm not using the simplified ones because I have to add them together. And remember, when you add fractions, you got to have the common denominator. But 1 plus 2 plus 3 ends up being 6. So this is 6 out of 6, which ends up being 1. And again, if you look at the spinner, red, yellow, or green, well, that's all 6 of them are either red, yellow, or green. So it's certain that you're going to spin one of those. All right, last problem here involving the alphabet. So you write each letter of the alphabet on a slip of paper. All the slips of paper are the same size, so you don't know if a bigger one is a certain letter or anything like that. The slips are placed in a bag, and you take out one slip without looking. So what's the probability of getting a vowel? Well, remember the vowels are A, E, I, O, and U. Well, that's 5 letters out of the 26. So 5 out of 26 that you'll get a vowel. Now a consonant, well, those are all the letters that are not vowels. Well, if we have 26 letters and 5 of them are vowels, that means 21 of them are consonants. So 21 out of 26 would be the probability of reaching in there and grabbing a consonant. The next one, find the probability of getting the first letter of your name. Well, you only have one first letter in your name. So that would be 1 out of 26. Probability of reaching in there and grabbing that letter. The next one, finding the probability of getting the last letter of your name. Well, again, you only have one last letter in your name. So that probability would also be 1 out of 26. All right, once you've answered all the questions on the video here, let me know. I'll check it, and I'll get you your homework sheet here, which is workbook activity 68 and 64.